In this presentation, we'll be going over the chemistry of depression and its treatments. Major depressive disorder, which is also known as depression, affects more than 300 million people worldwide, making it the world's leading cause of disability. The purpose of this presentation is to investigate the chemical basis of the disorder, as well as some of its treatments. To do this, we will discuss the background of this disorder along with its mechanism, treatment, and overall significance. There are two main types of depression, exogenous and endogenous depression. While exogenous depression has a clear cause and can be treated with psychotherapy, endogenous depression often does not have a clear cause and is usually due to an internal biochemical problem. For this reason, pharmacotherapy is often used to treat it. Because depression is such a widespread disorder, being known as the common cold of mental illness, it also has had a lot of research done on it. For example, we now know that depression occurs among people of all ages, races, and socioeconomic statuses, and that females outnumber males in a 2-to-1 ratio among depressed clients. So now we'll be going over the mechanism of depression as well as its treatment according to the monoamine depletion hypothesis. A monoamine is a type of neurotransmitter that contains an aromatic group and an amino group. So this can be seen within serotonin, dopamine, and norepinephrine, for example. One that is very important in depression is serotonin, which is involved in one's sleep, appetite, and mood. And people with depression are hypothesized to have low levels of serotonin. The monoamine depletion hypothesis was first formed in the 1950s, when patients were prescribed the drugs reserpine in order to control their high blood pressure. But what the doctors found was that depression was a side effect for approximately 20% of these patients. Because reserpine diminishes the number of monoamines in the brain, as it's a monoamine antagonist, it was hypothesized that depression could be caused by a deficiency in monoamines. The effect of antidepressants is that they essentially bring the patient from the basement to the ground floor, but no higher. And there are a few main groups of these, including SSRIs, or selective serotonin reuptake inhibitors, SNRIs, selective norepinephrine reuptake inhibitors, tricyclic antidepressants, and monoamine oxidase inhibitors.
Now we'll be discussing the mechanism of monoamine oxidase inhibitors, a class of antidepressants that increase the amount of monoamines in the brain. Monoamine oxidase is an enzyme that breaks down serotonin, dopamine, norepinephrine, and other monoamines that are involved in major depression according to the monoamine depletion hypothesis. Monoamine oxidase inhibitors inhibit the activity of these enzymes so that the amount of active monoamines in the brain increase, in turn treating depression. However, because they can cause side effects without careful management, monoamine oxidases are often used for treatment-resistant and atypical depression when drugs, such as SSRIs, fail. Monoamine oxidase needs an important cofactor, known as FAD, or flavin adenine dinucleotide, to break down monoamines. FAD can oxidize monoamines via a reaction at the 5' nitrogen site on the isoalloxazine ring. This diagram shows the proposed process of the oxidation of a monoamine. The monoamine, whose general structure is depicted at the bottom left, transfers an electron to a carbon on the isoalloxazine ring, causing the carbon-nitrogen double bond right here to break and giving the 5' nitrogen an extra lone pair, which is demonstrated through arrow pushing. After this step, the bond between the monoamine nitrogen and the carbon breaks, as the electrons shift to form a double bond between two carbons in the ring, forcing the double bond between the carbon and the nitrogen right here to shift to form a lone pair on the nitrogen atom right here. The extra lone pair on the 5' nitrogen is used to form a bond with the hydrogen on the monoamine, breaking the bond between the hydrogen and the carbon. This process is known as a nucleophilic addition, where a nucleophile forms a bond at a carbon center to break the double bonds and form sigma bonds. Monoamine oxidase inhibitors act similarly. This is the structure of an irreversible inhibitor, in this case selegiline, also known as deprenyl. The basic chemical structure of irreversible MAO inhibitors is shown next to it. This molecule can form a covalent bond with FAD to prevent monoamines from binding. As we can see in the diagram, the MAO inhibitor can donate electrons from its triple bond to form a bond with the carbon on the isoalloxazine ring, causing the shift of electrons to the 5' nitrogen right here. This bond is then broken to form a double bond between the carbons, which causes a shift of electrons right here to the nitrogen atom. However, since it is favorable for carbon to have 4 bonds, it can now form another bond with the 5' nitrogen atom, forming the final structure to the right. By binding irreversibly in this fashion to MAO, the inhibitor prevents the oxidation of monoamines and thus increases the amount of these neurotransmitters in the brain.
Knowledge of the biochemical basis of disorders such as depression has great significance. For one, this knowledge, along with the introduction of antidepressant medications, has led to much more evidence-based treatment of those with mental disorders, as well as further research into the neuroscience of these disorders. In consequence, we have seen a move away from mental health asylums and toward treatments that are more accessible and ethical. In addition, this knowledge has solidified depression as an illness that deserves serious attention from physicians, and thus further aided in spreading the availability of effective treatments for this disorder. However, there is still some debate over the monoamine depletion hypothesis. While the hypothesis is practical and has been used to treat disorders effectively, it appears to be incomplete. For example, the drugs discussed in this presentation only begin to work after a few weeks for patients, even though they should be immediately increasing the amount of monoamines in the brain. Although multiple reasons this may occur have been suggested, there is no real consensus among physicians today. In addition, there is great difficulty in measuring the amount of monoamines in the brain directly. And for this reason, there is not much direct evidence measuring the amount of neurotransmitters in the brain that supports the monoamine hypothesis of depression. Therefore, we hope that researchers in the future can improve upon our knowledge of this disorder so that we may treat and prevent this disorder more effectively. Even in developed nations such as the United States and Japan, the stigma against depression remains to be both widespread and strong, as found in a survey conducted by Shoji Yokoya and others. Although we may be fortunate enough to know better, many believe that depression is the result of laziness and the result of one's inactivity. They don't completely understand the biochemical component of the illness, which indicates that those suffering from the disorder will have a disturbed mood and decreased motivation due to a deficiency in monoamine neurotransmitters. By spreading the awareness of the chemical basis of this disorder, we hope to fight the stigma against depression, and studies have shown that this can be effective. As Angela Parsasip and Leonardo Cabasa have found, despite widespread U.S. stigma against mental health, increasing the mental health literacy of a population tended to reduce the stigma and social distance between the general population and those who were mentally ill. This trend was especially prominent with those diagnosed with depression. Therefore, we believe that the distribution of this knowledge is crucial to the acceptance of those with mental disorders such as depression in society, and hope that this may also reduce the stigma around receiving treatments, such as therapy and medications. In summary, depression, according to the monoamine depletion hypothesis, is based on a deficiency in monoamine neurotransmitters in the brain that leads to a depressed mood. Treatment drugs act against depression by increasing the amount of active monoamine neurotransmitters. Overall, we believe that depression is a grave, widespread, and debilitating disorder, but we also believe that it can be treated and destigmatized with proper knowledge of its chemical basis.